Okay, your assignment for today is to work with an epistasis pedigree. We just learned what epistasis is, and we're now going to apply that to an actual scenario. We have three genes, the W, the Y, and the D gene. W and the Y are epistatic to each other. That means that one impacts the other. If you notice, what starts to happen on the W gene is there is a gene that controls if you can make a pigment or if you're automatically lack of pigment or white. So if you have inherited the dominant W gene, then you are immediately lacking pigment. So regardless of what you inherit as a Y gene, you won't show it phenotypically. That doesn't mean you don't genotypically have it. We still have to figure that out. If you have a recessive W, that means you have the ability to be pigmented, and then you can look to see what the genotype of the second gene is to determine if you're yellow or green, using simple Mendelian. Dominant is yellow, recessive, that's a smaller Y, is green. The third gene, disc, does not impact, so it's just a typical Mendelian. There's no impact of color on the shape of the actual, this is a P. So what starts to happen, we're going to number your pedigree from starting up here, and this is person or P plant 1, all the way down to 14. I'm giving you the phenotype of each individual plant. Sometimes it's unknown to cause a little bit more, like you got to work around it. So what you're going to do is you're going to look at each phenotype. For example, the first one, phenotypically, you know, is white and disc. So underneath each of these squares or circles, you will have to fill in 6 different letters. You're going to have 2 genotypes, or 2 letters for the first genotype, 2 letters for the second, and 2 for the third. So from just the immediate phenotype, white, disc, all we know of the 6 letters, imagine that there are 6 lines underneath each of these. That's kind of how I would approach that. And you're trying to fill in as many lines as possible underneath each little square or circle. If they are white, disc, that means that they must have inherited at least a dominant W. So I would go down and keep them in order. I would put the first 2 lines be W's, the second 2 lines would be Y's, the second 2 lines would be D's, just to keep everything straight. So put a capital W in the first line right there. Leave the second one blank because we don't know automatically if it's a homozygous or heterozygous phenotype. We're not sure yet. The second gene is completely masked by the W gene, so we know nothing about the Y. So the third and fourth line should be blank. But disc is the dominant, so I would know on the 5th line that there is a dominant D. I do not know if it's heterozygous or homozygous, so therefore what I need to do is move on. If I go to number 2 and I see green, disc. Green means that they've inherited 2 little Y's. So that means the 3rd and 4th line, if you're again imagining 6 little lines down here, the 3rd and 4th must be little y. But in order to have a green pigment, that must mean that the plant is pigmented. It has to have the capability of being pigmented. So automatically, that must be the phenotype that's recessive over here. So now I can fill in lines 1 and 2 as well. So I have a little w, little y. And disc, I'm in the same boat. I've got to put the capital or dominant D there, but I do not know what the recessive, if it's a dominant or recessive. So I'm going to leave that last blank there. So right now, that gave me a lot of information. I have 5 of my 6 genotypes filled out. So I'm going to keep going. Number 3, I know nothing about. So I literally have 6 lines, unknown. 4, unknown. So what you're going to do is you're going to go through each and every single one of these, looking at number 5. That says homozygous phenotype. That doesn't necessarily mean dominant or recessive, but once you figure out what the first, if by process of elimination, what you're going to start to do is you're going to say, okay, this offspring is the parent, has parents here and here. What must they have passed down? If they had to have passed down a little y, then what that says is I'm telling you automatically fill in both of them. It's kind of like a little hint. That doesn't mean that they're all going to be little. But once you figure out what one letter is for the W, double it, because I'm guaranteeing it's going to be the homozygous for that. Then you figure out a Y, double it. Then you're going to figure out the D, double it. It could be dominant, recessive, dominant. I'm not telling you it has to be all of the same variation, but that's what that means for homozygous phenotype. You go through each and every one of these. For this one, homozygous yellow is also homozygous disc as well. Homozygous yellow, homozygous disc. So those are your hints. Your job today is to fill in the genotypes of each and every one of these 14 individuals on this pedigree, then what you'll do, you are going to send me a copy of the picture that you have produced, and I'll check it over. My hint to you is that there are 5 unknown lines. So spread out amongst all 14 of these individuals, you will only not be able to figure out 5 of the alleles. All right. So there's 6 here, there's 6 here, there's 6 here. So total 6 times 14, do the math right off the top of your head. What is that, 84? I have no idea. That would mean that only 5 of the 84 alleles are not known. So you would just leave them as blank. But you should be able to fill in every single one. To get a 2, you need to be close to that value. If you submit one and it has like 25 blanks, you're not getting full credit for this. All right? So there's your assignment for the day. Good luck. We'll be in touch.